Alright, so let's now solve the binary tree level order traversal problem. It's classified as medium on LeetCode, and to be honest, at first it could be a bit intimidating, a bit tough to solve, but once you understand what's going on, it's actually not that difficult. I actually really like this problem. So what happens is what's supposed to happen. Well, let's begin by talking about the first three traversals which we did, which were the pre-order, post-order, and in-order. We discussed how we're supposed to traverse through uh, each example, and whether it's left, root, right, or root, left, right, or left, right, root, depending on the variation. In level traversal, what's going on is we're actually looking or searching up the elements at each level, literally. So for example here, and it's from left to right. So for example here, at the first level it's just 3. On the second level it's 920, and on the last level it's 15.7. So and that's exactly what we're returning: 3, 920, and then 15.7. Opposed to, for example, um, pre-order traversal, where it was root, left, right. So for example here, if we were doing pre-order traversal, we'd add the 3, then we go to the left, we'd add the 9, then we go to the left, go back, and then check everything. Here we're actually checking at each level. So like I said, 3, this is the first level. The second level is 920, and then the last level is 15.7. So like I said, it could be a bit difficult at first, but once you understand how it works, it's actually quite simple. And the way we're going to solve this is by using a queue. In Java, there are stacks and queues, and stacks and queues essentially operate the same way they do in the real world. For example, if you go to a fast food chain, who's going to be served first? The first person who walks through that door, right? The first person in that queue. Whereas a stack is if you pile things on top of each other, which object would you be able to remove first from that pile? Obviously the top object. So stacks are last in, first out, whereas queues are first in, first out. So that's the first thing we need to understand before we solve this problem. So yeah, let's go. And one more thing I want to mention is that in this question they want us to return a list of list integers, where we really are used to seeing just list of integers or list of strings or list of characters. Here they're asking for a list of integers, and what that looks like is literally like the output. So what a list of integer typically looks like is similar to an array. And then a list of lists is literally, so you have this huge list, and within it there are other lists, sublists. So like here we have this list, which is a 3, another list, which is a 920, and the last list, which is 15.7. It's not very confusing. It's just the way we're grouping each level within the list, right? So the first thing we're going to do is we're actually going to be creating that list of list integers. So let me just list of list integer. We'll call it level, or we'll call it result, and equals new list, new array list. You can't create a list to a list, doesn't exist in Java. And then the first thing we're gonna do, actually I mentioned in my pre-order, in-order, and post-order traversal videos that most binary tree problems you'd solve via recursion. This one is an exception. This one we're not going to be solving through recursion. So the first thing we're going to do is, because they gave us this tree node root, which holds a value and points to the left and right subtrees, we're going to check if it's null from the beginning. And if it's null, then we're just going to return this list of list integers which we created. It's going to be empty, so that's going to be the output. So if root is equal to null, just return result. Alright, so before we continue with the code, I actually want to explain what we're going to be coding before we write it. So I mentioned earlier the ideas of stacks and queues. In this problem, we're just going to be using queues. So in other words, we're just going to be using the case where first in, first out. And how this works is we're first going to create an empty queue, and then we're going to add the root which they gave us in the given to that queue. And obviously this root holds the value within it as well as pointers to the left subtree and the right subtree. What we're going to do next is we're going to iterate in a while loop. We're going to say while this queue is not empty, and initially because we have the value 3, it's not going to be empty. We're going to create an integer called level size, which returns the number of elements within this level. How are we going to do that? By checking the number of elements within the queue. So in the beginning, in the queue, it's empty. Then we added 3. Then we said, while the queue is not empty, it's not, it has 3. Int level size is equal to queue.size, which is 1, because there's only one element. So level size is the number of elements within each level, which is just 1 in the first iteration. And we're also going to create a list of integers, which is supposed to go in the list of integers. So we're essentially creating this part called current level, which is going to be an array list, but we're going to be filling it up with the elements of each level. And the way we're going to do that is through a for loop, and we'll see in just a moment. So let's reach that part, and then we'll cross that bridge when we get there, basically. So after we say if roots equal to null, return result, we're going to create the queue itself, which takes tree node, right? Because we're adding the tree nodes of the tree, we're not adding integers. Let's call it queue, doesn't really matter, equals new linked list. This is how you create a queue in Java or a stack. No, actually stacks you can create stack something, stack equals new stack. It's just for queues. And then we're gonna do queue.add root, like we said. And then while queue dot is empty, while it's not empty, in other words. And then we're gonna create the int level size, which returns the number of elements or the number of nodes within each level. Int level size equals queue dot size. And then we're gonna create the list of integer. Let's current level, which is equal to new array list, and initially it's empty. Alright, now what we're gonna do is we're gonna iterate through each level at a time. So what I mean is for int I equals 0, I less than level size I plus plus. So what are we gonna do here? When we say I is less than level size, we established that in the first iteration, level size, we'd only have the node 3 in the queue, so level size is equal to 1. We're saying for int I equals 0, as long as I is less than the level size, so it's less than 1, what are we gonna do? We're gonna create a tree node, another node, which is equal to queue.poll. So remember we had the node 3 in the queue. What .poll does is it removes that node from the queue and it returns it. So we're returning it and we're putting it in node. And then what we're gonna do is we're gonna take the list that we created, current level, and we're gonna add to it that node. We're gonna add its value. Remember, because nodes contain integers as well as pointers to the left and right subtree, but we want to return a list of list integers, and we created a list of list integers, and then here we created the list of integers. So if we put a node, it's gonna crash, it's not going to work. Instead, we need to use node.val. We want to return the integer aspect of the node. And then after, what we're going to do is, because if we do this, then our queue is going to be empty. And if our queue is empty, then we'll exit the while loop and the code is done and we haven't traversed through each level of our tree. So what the next part is, we're going to say if node.left is not equal to null, then add node.left to our queue. And then additionally, because remember I said in the beginning, in level order traversals, we go through each level from left to right, so 3, and then the next level is 9, then 20. It's not 20, then 9. Then we're gonna say if node.right is not equal to null, then queue.add node.right. And then, so after that, if you remember, we had a list of list integers called result, and we actually need to begin adding those list of integers within result. And what current level is a list of integer that stores the elements, the integer value of our nodes of each level. So after the first iteration, our current level has 3.val, which is 3. And so what we're going to do is we're going to add result.add current level. So now our result is no longer empty. It has one list currently of integers, which is just the first level 3. And then once we reiterate through the while loop, current level is going to be created again. So the value of 3, which was in current level before, is going to be overwritten, and it's going to be empty again until we go through the rest of the code, and we'll take a look at the example in just a second. And then finally, the last line of code is just that we have to return result. So let's look at an example real quick within this tree. So first, we created a list of list integers called result, which is initially empty, and we're checking if root is equal to null. Is it? No. Obviously, we have a value right here. Return result, so just forget this. Next, we're creating a queue, and in that queue, we're adding the root value, which was given here, tree node root. We're adding root so we can begin. Now we're saying while the queue is not empty, which it's not because we added the root value, int level size is equal to queue.size, which is 1. We're creating a list of integers called current level, which is going to store the nodes, the integer value of nodes in a list of integers called current level, and initially it's empty. And then we're going to be iterating through the level size. So for int I equal to 0, as long as I is less than level size, initially level size is 1, I begins at 0, so I is less than, so 0 is less than 1. Tree node, we're creating a tree node called node, which is equal to the element. Oh, so queue.poll removes, like I said, queues are first in, first out. So queue.poll removes the first element, and it's going to return it and store it in node. We'll take a look at 920 in just a second. Then, since we have this node now, which is equal to a value, we're going to take our list of integer called current level and add to it node.val, because node is a tree node and we're storing integer, an object integer in our list, not object tree node. And then after that, we're checking if node.left is null. If it's not, nothing. If it's not null, then add this element to our queue. And then we're checking if right is null. If it's not, add this element to our queue. So what's our queue now? Remember when we did queue.poll, we removed 3 from our queue. And now in our queue is 9 and 20, and 9 comes first because first in, first out. Then we're adding to our result, which we created up here, right here. We're adding the elements within current level. So remember here we stored in current level the value of our node in our queue, and then we're returning the result once this is complete. So after we do this part, we just added 9 and 20 to our queue, and then we added 3 to we added a list that contained 3 into our list of integers called result. Now we go back up here. Is our queue empty? No, because it has 9 and 20, and now our queue size is equal to 2. We created our current level is now overwritten to be an empty array list, and we're iterating through the level. So I is equal to 0, I is less than 2 now. Tree node, we're creating a node which is equal to queue.poll. What does that remove? It removes the 9, so our node is now a 9. And we're adding the value of our node, which we're pointing at 9, which is just 9. So current level, our list of integer called current level, now contains the value 9. And then we're checking if node.left, so if 9.left is not equal to null, which it is, so we don't add anything. 9.right, also null, so we don't add anything. Result, so before we do result.add, this is where the for loop comes in play. So after we finish these 2 lines of code, we increment I, so now I is equal to 1, which is still less than level size, which is equal to 2. We have a tree node which is equal to queue.poll. Remember, we removed the 9, so all that's left in our queue now is 20, and we stored it in this variable called node. Now we removed 20 from the node and we stored it in node, and we add the value of this node, which is 20, into our list of integer called current level, and we're checking if node.left is null, which it's not, it's 15, so we add 15 to the queue, and then we add 7 to the queue, node.right, and then we increment I again. Now I is equal to 2. Is I less than 2? No, so we exit the for loop, we do result.add current level, and now current level contains a new list which contains the value 9 and 20. The value is 9 and 20. Now our result contains 3 in a list on its own, and it contains 9 and 20 in a list of its own. And then we go back to the while loop. Is the queue empty? No, because we added 15 and 7, and we do the same process again until the queue is empty, because after we remove 15 and 7, if you notice, there's nothing to the left or right of 15, there's nothing to the left or right of 7, and once we do queue.poll to 15 and we do queue.poll to 7, our queue is going to be empty. We're going to exit our while loop, and we're going to return result. So let's submit and see if it worked. Perfect. So yeah, I hope you found this video helpful. Like I said, it could be a bit of a difficult question at first, but once you understand what's going on, and I really hope I was able to explain it in an easy way, you'll find it easy too. So thanks for watching.